Hello, welcome back. Thank you for registering for this online demo. I would like to use your valuable time for small class and formal interaction. Please be feel free. This is casual talk for general interaction. Yeah, myself Vijay from Aditya Nana University, Andhra Pradesh, India. Today I would like to present some computational chemical data studies and physics role. Okay, many people interested to know about physics, but everyone feel very tough. But I would like to say physics is very easy thing, lively thing, and general. Today we are living in a beautiful earth. To study the atmosphere and to study the environment and to study the any of the object behind physics principles, physics is there. So nothing to worry about physics. Physics always free and easy to understand once we get the information. That is the motto and that is the concept. Today I am taking this small area. I would like to impress you some computational data studies, what is there and what is the fundamentals to study the chemicals by using physics principles. Once again, welcome you all for this wonderful online demo. For this demo, I was planned these of the contents I touch upon. Importance of computer in basic science. Okay. Then physics principles and theories. Some of the theories like Ab-initio methods and DFT studies and molecular dynamic simulations. And these are the small concepts. What is behind these concepts? Physics. I would like to explain some physics principles and theories which is connected to this DFT studies and ab initio studies and first principle studies, molecular dynamic simulations, and all. And I would like to give you some useful links and software programs. Some of the software programs are easy and free. Some of the programs are paid versions. Okay, we will discuss what is the thing, what are the possibilities to use these softwares, either paid version or free version. Then chemical data collections and applications. Using these softwares and some online tools, we are taking some chemical data collections and use it for some of the applications like biological applications and energy applications and all. And finally, interactive session is there. In that interaction session, we will interact in formal way. You have any doubts and questions, we will discuss in the end. Okay. First, importance of computer in basic science and life. I don't want to take much time for this title. We are all know very well. Without computer, we cannot imagine our life today. Like computer or smartphone or any technical gadgets. Without these things, we cannot survive, we cannot live in the earth. That is the present generation. It is mixed with our life and work and social connect to the people. We are all very well know about social media, WhatsApp, Facebook, YouTube, Google, and all. So why I'm taking this line. We need to know about computer, how to use, what are the basic facilities, what are the basic components are need. Everyone must know about these things. I hope you are all very well and familiar with these things. If you have any doubts or any further uses regarding computer or some software installation and these things, feel free to contact me. I am always available to do try to. And coming to the physics, I already discussed physics links to our life and link to society. So in our earth, we have many opportunities and many people are worked for a physics principles and theories. They are developed and still developing for the better life to better usage. So I don't want to explain these contents. You are all aware of these contents. Okay. This is links physics. I shown very small things and many things are connected to the physics. So everything is a physics. It based on the some rules and theories. Before Newton we have a physics. After Newton also we have a physics. But the concept is after Newton he is saying some principles. First law, second law, third law. But using that laws we can understand the things much more better. Okay. Before many things are happen, many things are there, but once the theory is developed, once the principle is developed, then only we can understand the things easy manner and to useful contents. So coming to the point, I just want to start these things from spectroscopy. We are all know about sun. Sun is self-radiated. You are, what is the fuel of sun? Anybody? Sun is the self-generated radiation. That radiation comes in a ray, but the ray not sorry that ray don't have to get some any media. Without media, that light propagates. So here I am showing one simple example. We are all very know about these things. Uh, inst- Instant ray and reflections and diffractions, and these are under the spectroscopy. Uh, for this, we need to know about electromagnetic spectra. That spectra contains some regions. Okay, we are all very well and we are all very familiar to this spectra. For this spectra, we are studying some contents to understand the things. So some applications like XRD, we are know about X-rays and some pictures of the structural information. Like if we take any crystal or powder, we need to go for X-ray. Why? Because we need to confirm the structure and size, same as electron, same term. For that same term results we have for the picture of total uh, particle size or formation of particles, how they are aligned. These things we can know from SEM and TEM. Same as lasers. Laser taking many examples like we have FTR spectra, UV spectra, Raman spectra. All these things, the source is laser, and same as photoluminescence spectra, UV spectra. These things taken from the protons. Proton beam means ion beams, and electrons also having their electron beams. For these beams are generated by the accelerators. So accelerator physics is developed. For these, all the spectra based on the source. That is light source. That light source is important. If we take any laser, that is a good source. And if we take any ion beam or electron beams, that is also a good source. For these things, we need a source. So the source is main, and the study of content is main. These things are connected with the spectra. It is interact with the matter. That was a clear idea. And we just go with the biomolecules. I just taking these things for examples. If we take any atom, small molecules or proteins, and virus or organism or bacteria, these things are in different scales. The different scales displayed in the clean manner. This this for a study of. For this, I just show you what is the scale determines. The scale 10 power of minus 15 to 10 power of 0, that scale speaks everything. If we take one small example for a graphene, that graphene looks like this. If we just go with a zoom, it will some construction. And we go again electron microscope, and we go with a scanning tunneling microscope, we can see the atom structures. Okay, that atom structures we can reveal when the source of light speaks the structure of a molecule. That structure of molecule speaks the internal atomic structure and the energy levels and everything. I just want to show these pictures for scaling. These tiny scales we can see by the source, and we can analyze. Then only we can say that structure is this, that structure helpful to the some other studies or applications purpose. So in that case, this is a organic substance. Once that organic substance is very small substance, if we go with the complex, that structure be like. And I just shown you this is a one organic substance, like one organic molecule. This number of molecule, when it is increased many number of molecules like this, we can see this is protein. So that much of complex structures are there. We need to study how. I just tell you how. And same, just we take one drop of our human blood or any blood. That blood contains a cell. In that cells, and it mixed with a plasma and buffy card, and these are the contents in blood. That blood having different contents. I just take only one red blood cell. Red blood cells, why red blood cells looks in red color? Because of hemoglobin. That hemoglobin having one nature. That nature depends on the structure. The structure speaks the content. What is that content here? Red blood cells. We need to determine the red blood cells. How that we are all very know about groups, blood groups. So the blood groups depends upon the cells. That cells are we generally discuss like hemoglobin. That hemoglobin having the structure, I just take one primary structure and secondary structure and third and quarter means fourth structure. This is the internal structure of a red blood cells, not a red blood cells. That is a human hemoglobin cell. Okay. For this, we need to study the structure of a red blood cell. We need to study about hemoglobin. All these contents looks very clear, but the practical is not look like that. This is the beauty of computational data studies. This is the beauty of computational studies. Computational studies helps to understand the different structures for various applications, for various studies. I just want to show these pictures for idea of visualization, for importance of visualization. So these are the people work for these visualization theories like Heisenberg uncertainty principle. We know Schrodinger. Many times we heard about Schrodinger. Schrodinger wave equation. Without Schrodinger wave equation, we cannot define any density functions. We cannot define any harmonic generations. We cannot define any single body particles or many body particles. We cannot define. For all these Schrodinger wave equation and time dependent and in time independent things very important to us. Same as Hetris and some people work for this computational chemistry and they have awarded Nobel Prize also. Khan theory also we have. We'll I'm not go into the details. I just want to show pe- what people work for these things. We are all very familiar with these things, and some other people also there. Like we are all aware of that people and what they did. Then only we can understand the concept of principle or any theory. See here, Avogadro law we have, and the atomic theory and based on chemistry, and modern father of modern chemistry. How they are modern of father of physics or father of chemistry. They worked for a theories. They worked for a contents. So these are the Indian people work for computational chemistry for data studies and still they are alive. He is gone, but IIT Indore professor is there. He worked people names I just want to mention here. Sorry for the interruption. Small internet issue. Okay, these are the people work for computational chemistry in India and various parts of our world. So finally, what is computational chemistry? Why this computational chemistry is important? Okay, chemistry in the computer instead of laboratory. Okay. While we go for a chemistry, we need a laboratory. Instead of that laboratory setup, we need one computer with a high high and internet facility and some internal graphic cards and internal RAM and supporting GB memory card and everything we need. Then only we can use that computer in perfect manner. Same as in laboratory, we need some apparatus like funnel or test tube or chemical liquids uh, and all. Same as in computer also have some software, some components like RAM and updated versions, OS and all. Okay. Same as why this computational chemistry important. See, computational chemistry has become widely used because of dramatic increase in computer speed and design efficiency, quantum chemical algorithms, and the computer calculus embedded with explain rationalization known chemistry and explore new and unknown chemistry also. We can do the things easy. Same as for this we need a some structure like any of structure benzene having that structure ring structure. Okay, same as we take any one structure, we can go with a validation and interpretation and prediction. For that prediction we need some dynamics. For that dynamics physics principles are used, and same as reactivity, we can observe the reactivity and we save that material useful for some other applications and some applications we can. So here we are giving insights, not numbers. Okay. Everyone thinks some measurements in we just taken some numbers, but that is not useful. We just go with the insights. What is the content involved? What are the things are involved? We need to explain. Then only that work will work. same. And we need a one flowchart. I just give you small idea of this computational chemistry or computational data study. So we just take any of molecule. I already explained for molecule structures. We just take any of molecule like that hemoglobin or some benzene or something. We just construct that molecule in that computer program. We have a lot of programs. We just give the coordinates, graphical or by hand. We can select by the default. For the coordinates is Cartesian coordinates or internal coordinates. These are depends upon the structure or any molecule. Okay. Same, we just go with a program. We have many programs. I just want to go with a Gaussian or Gassam or geometry charm and many things. Same as for these things, why that program is needed to study the molecular properties. Molecular properties means structure, energy, orbitals, or molecular orbital interactions. For these things, after that study, we just get some spectra. The spectra having some regions, right? That region is IR, Raman, UV, NMR, X-ray, and all. And we go with the interpretation. Why this interpretation is for that molecule we have a experimental data. For these theoretical theoretical properties, we just predict these properties by use programs. Then we just go with a interpretation with experimental data. Then only we will confirm that what are the applications are involved. We just go with a confirmation test. So, like in chemistry, we have a confirmation test, like alcohol test, and that some other tests are there. Like when I was studying intermediate, that is salt analysis. In salt analysis, we have a confirmation test for iodine, and we have a confirmation test for rings actually. Sorry, I forgot actually. And same as that confirmation test, we just go with a theoretical information with the experimental data. So these are the green aspects involved in computational chemistry and computational data studies. We need to see calculations are very safe when we compare with the experimental. Some dangerous experiments also involved. So easy to perform. I already said, and less cost also, and it is not affected to the environment, and it is not any chemical systems or experimental related limited and so and all. Okay, we just go with the information. Why? What are the properties we can calculate? These are the all properties we can calculate. I just touch some of the things. Optical and magnetic and vibrational dichroism and spin orbital couplings and some K points, density matrix, excitation states, solvent effects. We can change the different solvents also. All properties, all the studies already written by some programs. We use that programs, we can calculate these things. And I just given some of the examples only. There is many properties we can calculate. So all the calculations and all the properties depends upon the theories. The theory depends upon the physics. Physics discuss with the mathematics only. So mathematics is a language of physics. So we, without mathematics or without numerics, we cannot go with any technique. Just and without physics principles, we cannot go with the chemical or biological activities. For this, I just introduce some Ab-initio methods. That Ab-initio methods have Hartree-Fock method is a old method. Present everyone using DFT functions. It depends upon density functional theory. It is time dependent and time independent for the Schrodinger wave application. So Schrodinger wave equation plays a important role. Same as semi-empirical method also. The semi-empirical methods also many methods are there, and molecular mechanics and molecular dynamics. I just want to show what is the information. If anybody wants to discuss more, and we will discuss after some time. Same and some famous theories I already discussed. Hartree-Fock and density functional theory. Nowadays, many people working with these theories, but nobody know about what is that theory, what looks like, and what it determines. Nobody knows. The applications speaks, but the concept is different. The theory is different. We need to know about the theory more and more. Then only we can understand the things easy manner, and we can explain the things. So finally, these are the some techniques and some of the tools I am working present. So if you have any queries regarding these concepts, I can handle it. And moreover, some other theories and some other works also I extend, but I am not confident to explain. But these concepts I can explain in a confident manner because I am working in these fields present. Okay, we just go with a small demo on Gaussian. We have a Gaussian package. I have a licensed version. All the previous slide having that concepts like electronic structural determination and geometrical optimization and visualization and potential energy surface and frequency calculations, vibrational, rotational, and electrical energy band gaps and calculations of nonlinear properties and electronic dipole moments and all the concepts we I just done with the Gaussian, and some other packages are there, but Gaussian is limited and it is having some limitations also. Less than 100 atoms we can use. So this is Gaussian 5 I am using for visualization 6.4 version. So this is benzene structure. We are all very well, and these are the some ring structures. This is, and we have the the elements, all elements and the structures also already preloaded. So we just take that pictures, we just take that structure, and we construct whatever we want, what molecule we have. We can. These are the formal groups, R groups. We are all very well aware of these R groups. So R groups also there. If there is any group is missing, we can construct the like like this. So I just want to run only benzene molecule. For this, I just take new and this benzene structure. I just paste it here. I just go with the calculation setup. For this calculation setup, I just we can we can calculate all energy optimization frequency or both optimization and frequency and IRC and scan and NMR and stability we can calculate. I just go with a energy and we have methods. We have a lot of methods. I already told about Hartree-Fock method, DFT method. These are the methods. Before going to that method, we just go with a ground state or excited states. Any of state we can see here DFT, MP2, MP4, CCSD, and now MP6 is also updated, and that is in different and spin also we can define. This is the basis set. This is the dipole moment, and we can give any title. I just giving the benzene title as title, and we can go with the links. That links memory limit and shared partners and everything is it by default only. I don't want to change any. See here solutions. We have different solutions. The default solution. I just go show you these solutions. We have acetone, ethanol, methanol, water, DMSO, aniline, benzene, CCl4. See, in our laboratory, we have these solutions. In that software also have that solutions in some data. Based on the program, we can run anything. I just show you that things. I just want to go with a noun without solvent. Without solvent is means it is in ideal condition. In laboratory, we cannot go with the ideal condition. In computer, we can go with the ideal condition. Ideal condition means without any impurities. We just take the core one. Here, benzene. Only benzene we can. There is any impurities. We just go with a known without solvent means gas phase. Okay. For this is the preview of that coordinates and all. See, we have six C's and we have six hydrogens. X, Y, Z coordinates. These coordinates we can change by manual, but here I would like to show that is the reason why I just keep all these things by default. Okay, then we submit our job. We give file name. We need to care about that file where we are going to save. Then we just save and we can run. The software package I have Gaussian 9. In Gaussian 9, it will run. It will take some, this is very small molecule, so it is not much time. But I re-recorded. I just show you the results after optimization. Here after the result, output will come like this for this checkpoint file and log file. Here the checkpoint file for further usage. For I am using the log file for the information benzene. file type, check file, and SP calculation. And this is the basis set. B3 LYP I used, and charge is 0, spin is singlet, and the energy. See here we can obtain the energy in Hartrees. We can convert into electronic volts and angstrom units and all by using. I show you how to convert the thing, and dipole moment also. See, this is the dipole in dBs. All these things comes in easy way. This is the beauty of computational data studies. I just give you that molecular orbitals also. See here, molecular orbital, we are all HOMO. HOMO means highest occupied molecular orbital. Here the highest occupied 21, and this is the HOMO. For this, I just show you the solid one and mesh. We can see positives, only positives over there, and we can see the negatives in different, and positive and negative we can the in that molecule having alternative. So I just remove, and now I am going to show you some more results. It impress you. See the result for vibrations. See, we are all studied for molecular vibrations, but in these computational studies, by using this computer, we can see that we can feel the vibrations. See, in benzene, how many vibrations you have? 3n minus 6 formula. Based on this formula, 30 vibrations is there. So that mode of vibrations, 1 mode, 2 mode, 3 mode, and the frequency also. So for based on this frequency, based on this, see 30 vibrations are there. The frequencies also. See here the frequency 3192. 3192 means CH vibration. So CH stretchings. The stretch. See here the we can see the stretches like that. In 27 CH is H10 H7 C1 H CH. Okay. And before the stretching also. And we can see IR spectra also. Based on the spectra, here CH vibration, and this is ring vibration, and these are the internal in-plane bendings and out-plane bendings. See, clearly we can see if we select any peak, that corresponding mode and corresponding frequency, corresponding infrared intensity, and rotational stretching also we can see. So this is the see if we take any benzene, we just go with an experimental, we cannot see these things in this visualization. So we cannot see, we can feel the experiment, that experiment is good, the benzene having the different properties, we can. But in computational data studies, we can see the information at a time. I just want to show you already published results for this optimization and frequency for one compound, that is 6 hydroxycoumarin. For this 6 hydroxycoumarin having 18 atoms, The vibrations, 48 vibrations. So that 48 vibrations, we can see the higher spectra, and we can visualize the content also. See, this is peak. The higher peak is CO, CO double bond. That is CO double bond stretching is there. Is around uh, 31 3100, and this is OH. And same. When we select any peak, respective vibration we can see in very clear. Okay, this is the vibration. And Raman studies. Raman spectra also we can see. We see the spectra and Raman spectra. We can see these things with less time, without no need of big sophisticated equipment and all. Okay, we need a experimental support, but before going to experimental, we can see these things by computationally. Then we can understand the thing. Then only we just go forward. If the results are good, we just go with a further proceedings. Without it's not good, we just leave and change the molecule and also. See here the Raman activity and infrared and frequency and dipole moments. We can see the things by numbers. The number speaks what is the vibration, what is the frequency, what is the intensity, what is the rotational values we can see. SCF, this is NMR spectra. For this NMR spectra, we just see each atom having their peak. And the charge also. See here the total energy we can see, and ATP charges also, and Mullikan charges also we can visualize. This is the Mullikan charges. This is the information. The engine also we have. I will show you properties. We can change the background and change everything we is possible for this label and naming and charge. Here Mullikan charges I am showing ATP charges and Mullikan charges. The color coordinate, color content also we can in the charge. Okay. Okay, we get back to our thing. Okay. I already discussed. I just given thought. This is a theoretical spectra. This is experimental spectra. Almost we can predict the right results. Once depends upon the basis set and depends upon the method of working. It gives you the accuracy. All these things based on the physics principles and the theories. We need to understand the theory. Once we understand the theory good, then we select what is the basis set, what is the method, what is the best one we can choose. Without knowledge we cannot choose any basis set or a method. So this is the concept. We already published these papers. We have. So this is the UV spectra also. That is UV absorptions, and this is IR. I just given for idea. In Spectrochemical Act, we published a paper in 2020, and many papers are there. And this is for one supporting work only. This is not a main one. Without assumptions, we cannot go forward. So, assumption is need. So, this work having that much of importance. So, I today I would like to show you some database. We have large database. Uh, from that database, we can take molecules directly. We can take proteins directly, and we can change the structures by using different softwares we have. I just shown you before that Gaussian, same as different softwares also we have, and I just explained you, and many people are working with these softwares. If you have any queries, we will discuss together. We sort out the programs. These are the database we have. Protein data bank, there is lot of proteins there. See, in our world suffering 2020 COVID, that COVID virus, that vaccine coming within months. How it is possible? Without any tests, without any trial runs, we just taken that vaccine. How? That that is possible by computational studies. In computational studies, they taken that virus structure and they analyze, and they plan to change their liquids or change their medicine over the virus. That virus reactions they observe, and they trial run and they tested. Many people are working in that area. ICMRA, we need to thank that ICMRA, Indian Medical Council. They done an excellent job. Based on the computational studies, they done the job in easy way. Once we have a data, we can analyze, we can sort out, and based on the results, we need to compare the things, and we finally finalize it. So same, we have a data banks, and the data banks have various structures. If you want to go with that structure, you just go with the website, uh, and chemistry also. For this chemistry, we need. I already shown that structures, and readily we can take the structures from this website also. That is PubChem, National Laboratory of Medicine. They are running. So that structure also, if we have any complications, we just go with the structure. If we want to change any structures, we can change this. Then we can readily available. So virtual lab also there. That virtual lab provides crystal structures and nanostructures and many things. Same as NanoHub. NanoHub also having their own structures, the database. Once we go with a sign in, we just go with a sign up. They give you the login IDs. For whatever you go, everywhere you have a login. Everywhere you have a login. You just go with the login. You will get regular updates and regular mails also. For these things, why I am mentioning this is to develop our knowledge, to acquire our acquire knowledge. We need to follow the websites. We need to follow many platforms. Then only we can get the information. So, and the material project also, that material project having their own database from the molecular molecules, and different compositions of nanomaterials and compositions of crystals and energy materials and biological materials and all. I just given the information for this. This is the structure of AC cadmium, and for for this data studies, it connects to research. Our research for drug analysis or material, I just mentioned you before, for vaccine, COVID vaccine, for drug analysis, drug discovery, all things possible by the computational data studies. Okay, and material science having their own platform, and molecular spectroscopy. I just given you information regarding IR spectra and Raman spectra or UV spectra. These are the things connected to molecular spectroscopy. That molecular spectroscopy based on the source. That source is laser or ion beam or any energy beams. That source is important. If the source is good, we can see clear picture of any structure. See, without light, I cannot see you. You cannot see me. So the source of light is very important, uh, and complex molecular dynamics, and all we have. These are the primary and basic understanding. I just given some small demo. That is the reason why I kept the title is demo. I don't want to explain all these things. I just want to show you what is the things are there, what are the possibilities, and why computational data studies are important. I just presenting you the database and theories and principles of this is the imaging techniques. So I just tell you SEM and TEM and high resolution and molecular dynamics. They having that scale and that length. Time scale we have, large scale we have. That based on the large scale, based on the time scale, only we can determine the information. Here the molecular dynamics are there. See in that molecular dynamics, micrometer level, microsecond level. Okay, and if we go with a optical microscopy, the optical microscopy almost meters. Okay, when we go with the same or electronic microscopy and quantum mechanics for the DFT studies, that is in nano level to atomic angstrom units. Okay, 10 power of minus 9 to 10 power of minus 15 also. Attosecond region we can go, femtosecond region we can go with the quantum mechanics. That quantum mechanics basically is a physics concept. So we need to understand the concept. So we need to know. We need to know about the mechanics, quantum mechanics or classical mechanics, the things of physics. But the applications and working mechanism all is different. Working mechanism is chemistry. The applications are biological applications or energy related applications. But the concept is physics based on the quantum mechanics or classical mechanics. Yeah. That is the thing actually. So now we go in computational scientist or data scientist or experimental scientist and R&D management and machine learning and many things. Many things are connected to the secure logins. So we need to break the login. For the break is some of the logins are free, some of the not free, but we need to care about these things. Without these knowledge, we cannot go with a data scientist or that computational data scientist. So we need to know. So finally, we have two types of research: experimental and theoretical research. Based on the theoretical research, only experimental research will come into the picture. Without theory, we cannot go with the experiments. If we go without theory, that experiment will fail or experiment explore. So these are the some fundamental types. I just want to show you what are the fundamental types we have. What is the importance of research? Why we are going to do these research? For this, I just nutrition, lifestyle, and new technologies, therapies, and citizens surveys or interviews, brain imaging, and generic tests, and all. So this is the cyclic process. So when we go with the research, we have a question. So then we go for a definition. We just go with a experimental or theoretical design, and we just go with a data collection and evaluation, and finally we just go with a report like publications or patents and some reports, theses, and project reports and all. So we need to present our report. So we need everyone wants that question. If the question is clear, report will come out. If you break any of this chain, you cannot go with a report. We cannot present any reports. Just if any research have their own question. That question give you the problem and definition. That question give you the experimental way of design. And the question will collect the data. The question finally justified with a evaluation. Then we go for a report. So finally that research is search, analyze, keep the data, save the data, publish the data. With the data, we have large database www dot world wide web. We can post it, we can take anything. Okay. These things connect to our minds. Today I am presenting some idea or some views of mine by how the wireless communication or wire communication. This is the ideas sharing to brain to brain. I just posted my idea in social media. You are all registered and come to listen these things, and some other people will see that recorded thing after some time also. So this is the connecting sites. So I just present you some idea of platforms. We have large platforms, LinkedIn, Check, OpenAI, and many things have come. But regularly, I am go with a WhatsApp and Google Scholar, of ResearchGate, LinkedIn, Scopus like elsewhere, Wikipedia, Facebook, Orchid, Messages, and some other organization also I have. So these things. So finally, I just give you my work view. Present, I am working with these softwares I have, and many softwares are added. This is old one. I just presenting you what I am doing, what I have. I already given the lines of work. This is the visualization of my work, and I'm always available in online. If you have any queries, you just contact me directly. I will try to help you, and I just take you some suggestions from you also. Yeah, thank you. If you have any queries, please unmute yourself and ask me, discuss the things.
Assalamu alaikum, sir.
Yeah, बोलिए.
Vijay sir, I am Zores Khan from Pakistan.
Yeah, yeah.
सर चलो मैं उर्दू में बोलूँगा, मेरी इंग्लिश इतनी स्ट्रांग नहीं है। सर मैं चाहता हूँ कि
कोई बात नहीं,
तकरीबन
हिंदी में।
हर 15 या जी सर मैं चाहता हूँ कि हर 15 या 20 डेज बाद हम कोई इस तरह का सेमिनार रखा करें रिलेटेड टू आर्टिफिशियल इंटेलिजेंस या नैनो टेक्नोलॉजी, जो भी केमिस्ट्री या इसके रिलेटेड हो। तो वो हमारे लिए फ्यूचर में भी बेस्ट होगा, अगर हम कहीं पर अप्लाई करें तो वो हमारे सीवी में भी प्लस पॉइंट होगा। तो इस बारे में सर आप क्या कहते हैं?
For AI technologies, there is large platforms. I just share you the information. If you have any queries, you write a mail. I try to answer you. For this today, computational data studies and all based on the AI tools. The AI tools helps us to get information with a short period. No worry about it. I just give you the information. You just follow. Okay. Thank you.
ओके सर। सर एक्चुअली मैंने मीटिंग थोड़ा सा लेट ज्वाइन किया, इधर आवाज़ का बहुत ज़्यादा इशू था सर, मुझे आवाज़ नहीं आ रही थी। तो उसके लिए मैं माजरत ख्वाह हूँ सर, मैंने बहुत ज़्यादा वेट किया इस
ठीक है, कोई बात नहीं।
गूगल मीट का।
I have a recorded video. I just posted you in YouTube. I just give you the link also. We have a YouTube channel also.
सर
You can see
विजय
the
सर
details.
मैं
Hmm.
ओके सर, मैं एक बात और बोलूँगा कि सर मुझे ये वीडियो भी आप मैसेंजर पे भेज दें, मेरा वो जोरेस खान वाला
I
वो
just
है
give
ना,
you the
मैसेंजर पे
link.
मैं
I
आपको
just
कोड।
give you the
ओके
link.
सर।
You just
ओके सर,
go
और सर आई
in
नीड,
YouTube. Okay.
सर आई आल्सो नीड द सर्टिफिकेशन सर।
We will plan. We will plan. No worry.
ओके सर, थैंक यू सो मच सर।
Okay, fine. Anybody?
Good evening, sir. I'm Sri Charita.
Yeah.
Sir, I'm just planning for a small project.
Okay.
So, want to purchase this Gaussview 6 as well as Gaussian 9 softwares. Can you please help me with
Yeah.
the
That
price and all?
I share you the price details.
Yes.
The price details also available in Gaussian website. I just share you. Don't worry.
Yeah, yeah, sure. How much it was for you, sir, when you have purchased it? Main
I
graph
purchased
estimate.
in 2017,
Okay.
16, I think. Uh, for my DST project, we have that fund. We at that time 1,20,000, I think, for
Okay.
lifetime for single user.
Okay.
But I am using in multi user. But it is working. At
Okay.
that
Okay.
time, they given that offer, but
Okay.
now I don't know exactly. But price cost is around 1,20,000 Indian rupees.
Both together, sir. Gaussview as well as Gaussian 9.
Yeah, both.
Yeah, sir.
Now that version is Gaussian 16 is updated,
Yeah, yeah, Gaussian
and
16.
the running version is Gaussian 9 only,
Yeah.
09. I
Okay.
just share you the details by mail.
Yeah, so one more doubt, sir.
Hmm.
Is your work purely theoretical or you're just taking it as a support for your experimental part?
This is purely I am taking theoretical work.
Okay.
For my theoretical work, I just taking some experimental results and all for support.
Actually, my background is from organic chemistry, sir.
Hmm.
I had no option apart from submitting my thesis in computational chemistry at the time.
Okay.
So it's a theoretical work. I had to defend my thesis a lot because it is theoretical. So all
Yeah.
our chemistry persons, they are expecting the experimental work.
Yeah.
And
The problem is that actually many people, chemistry people, basically I am talking.
yes, yes, sir.
Chemistry
They are
people wants only
mostly focusing on
experimental,
wet lab.
only
Yes, yes.
experimental.
Yeah.
But nowadays I am struggling to the same thing also, but
Yeah.
I would like to explain them to theoretical is important. Why that theoretical is important, I just added many theories and many properties of results.
Okay, I'll just
For
tell you one
supporting.
example, sir, of my thesis itself. So I have worked with a set of donors and acceptors to prepare conjugated polymers to replace silicon in solar cells.
Yeah.
So that's my actual project. So I have worked with around 18 pairs of donor acceptor combinations, and finally proposed two of them would be efficient.
Yes.
So I have defended a lot supporting my theoretical research. But
But
finally,
here,
the question they have
here,
raised is, you
yeah, yeah.
have proposed two of the polymers were efficient. Why don't you synthesize those two polymers? That was the question
No,
raised, and I have
actually,
no answer.
before we suspected and we predicted
Oi,
different
oi,
compositions, you already said for 18 compositions you tried.
Yes, yes, yes,
In
sir.
that 18 compositions, you just got two only, two
Yes,
the
sir.
best
Yes, sir.
ones.
Yeah,
So at that time, you just clarify them if you have any chance. In further same situation you will face, I just suggest you uh, just put that 18 compositions. If we take many compositions, we need to present many conformations also
yes, sir.
with respect to 1 is to 2 like that.
Yes,
If
sir.
we try to, we present at least 1.
Yeah.
If we try 10, we need to present 5
Okay.
along with that 10 also.
Yes.
Then only the people will see the theoretical results is looks wow. Why? Because many people presenting one or two results. That is
Yeah.
not good. If we go with a theoretical, we need to present all the result
Yeah.
along with confirmations.
Actually, my
One,
doubt
two,
is,
three, four, five. We
yeah,
can present these things in
yeah,
one page or two page. You need to present all the things.
yeah,
Why these things are failed? If you explain why these things are failed, that is worth.
yeah. Even my doubt, sir, if research to be successful, so we'll be successful when we are capable of replacing silicon with the proposed conducting polymer. So
Yeah, we can.
without synthesizing it, how can
Yes, sir.
we, how can we just
Yeah. See,
expect a new
we
type
need
of solar
we
cell
need.
in future?
Yeah, yeah. In theoretical, we can put any of element in that
Yeah,
composition. Any of
yeah,
element. We have freely available and easily available the database also.
yeah.
But experiment is different. For that, if we purchase any silicon, that is very high cost.
Yeah,
Not
it's
like
costly.
this.
So
See,
our
we
main
have a
concept, while
package.
main,
We have
yes,
we have
yes,
a package. We have a package. In that package, all the elements are embedded, inbuilt.
yeah,
So no need of any extra purchase. For this experimental, we need to purchase
purchase the chemical.
any of
Yes,
required element. We need to purchase again and again.
yeah,
That is the we you just to show them the results of this is the theoretical results I have. These are the possibilities I have. If you provide any financial, I just go with the experimental also. I am looking for that financial support for experimental.
yeah,
You just ask them.
yes, sir.
Nowadays in India, no one supporting that research also. Many people in Tamil Nadu or Kerala, in southern states, they are looking for only theoretical only.
Theoretical,
In
yes,
theoretical, it is very easy and less cost and less time, and we can produce more research. But
yeah,
that is not worth. But nowadays, without funds or without any support, we can go with the theoretical only. We cannot go with experimental. If they
yes,
support experimental, we can do the experimental also.
yeah. Okay, sir. Thank you.
हेलो विजय सर।
हाँ
हेलो,
हाँ हेलो
आपको
बोलिए
आवाज आ रही है? सर मैं ये
नहीं
कह रहा हूँ कि अगर आप जो भी जो सॉफ्टवेयर वगैरह है ना जो कि केमिस्ट्री के रिलेटेड हो ना, जिस तरह के गाजियन हो गया या और सॉफ्टवेयर हो गए ना, तो
नहीं
अगर आप उनका बैच स्टार्ट करना चाहें तो काइंडली मुझे भी उसमें लाजमन शेयर किया करें, ठीक है प्लीज। ये एक रिक्वेस्ट है।
see
और
see
दूसरा ये। जी।
these are the paid versions we cannot share you. If you have any work related to this, you just share me the information by document. I just try to do the things and I just give you the information or like the report.
विजय वजह सर मैं चाहता हूँ कि मैं ये जो गॉसियन सॉफ्टवेयर है ये किस तरह चलते हैं मैं इनका तरीका सीख लूँ, मैं ये चाहता हूँ सर।
Okay. In that regarding, you have many tutorials. I just share you the
ओके
YouTube link also. Don't worry.
ओके, थैंक यू सर। और सर आल्सो टेल मी कि आजकल किस तरह के हम प्रोजेक्ट कर सकते हैं केमिस्ट्री रिलेटेड। मैंने एक प्रोजेक्ट बनाया है कि हम जो पोल्यूटेड सिटी है हम उससे किस तरह कार्बन डाइऑक्साइड को न्यूट्रल कार्बन में कन्वर्ट कर सकते हैं। तो अगर आप इस तरह के और भी। जी
Okay. For carbon reducing experiments are there. I just give you one or two project reports. Previous already many people are done. You just read
ओके
out. After that, you just frame any questions by document. I just give you the answer by document.
ओके सर, थैंक यू सो मच सर।
Without understanding, you cannot do any project. For
ओके
your understanding, I just give you the information. You just go with that. We will discuss after some time.
ओके सर, थैंक यू सो मच।
Yeah, yeah. Thank you. Anybody? If there is no questions, I wind up, end up this program. Thank you for your valuable, wonderful support to making this program success. Thank you. Thank you, one and all.
Thank you, sir.
If you have any queries, please contact me by mail or any channel. I just give you the support. I try to. Thank you.
Okay, sir.